Hello friends, today we are going to give the proof of the theorem every convergent sequence is bounded। पर इसको प्रूव करने से पहले हमें कुछ चीज़ों के बारे में पता होना चाहिए that what is a sequence and what is the boundedness of a sequence। Now, a function whose domain is of the natural numbers is called a sequence. This is a denotation where domain is the set of the natural numbers. A sequence is usually denoted by these two symbols, where S1, S2, S3 are called the terms of the sequence. Now, boundedness of a sequence. A sequence Sn is said to be bounded if it is both bounded below and bounded above. If there exists K1, K2 belongs to R such that K1 is less than or equal to Sn is there less than or equal to K2 for all small n belongs to capital N, where K1 is the lower bound and K2 is the upper bound. So, a sequence is Sn is said to be bounded if it follows this such that it have a lower bound also an upper bound. So, it is bounded from both sides. Then we can say Sn is bounded. Now, come to the theorem that every convergent sequence is bounded. Let Sn be a convergent sequence as it is given. Now we have to prove Sn is bounded. So since Sn is convergent, from the definition of convergence, for each epsilon greater than 0 there exists m belongs to z plus such that Sn minus L less than epsilon for all n greater than or equal to m. So from this we get this Sn minus L less than epsilon, where we have taken epsilon is equal to 1, and by solving this we will get minus 1 less than or equal to Sn minus L less than or equal to 1, and we are adding L in all of them, then we will get L minus 1 less than or equal to Sn, L will be cancelled from here, then L plus 1. Let K1 be the set of minimum of the S1, S2, S3 to Sn minus 1 and L minus 1, that is the K1, and K2 is the max of S1, S2, S3. These are the terms including L plus 1. So we can have K1 is that is the minimum of the terms to less than or equal to Sn and less than or equals to K2, that is the maximum of all the terms including L plus 1. So we can say Sn is bounded below and bounded above. Hence it satisfies the condition of boundedness. So we can say that Sn is bounded. Hence we have proved that every convergent sequence is bounded. Hence proof.